Steps in Bairstow's method. Step 1. Make an initial guess of R and S. Step 2. Divide f of x by formula of x squared minus rx minus s using synthetic division. Neglect the rules for the remainder. Step 3. Label the result consecutively as b sub n minus 1, b sub n minus 2, b sub n minus n, where n is the degree or order of a polynomial. Step 4. Perform synthetic divisions on the result of step 3. Label the results as c sub n minus 1. Stop on c sub 1. Step 5. We can get delta r and delta s from the equation. C sub 2 times delta r plus c sub 3 times delta s is equal to negative b sub 1. And c sub 1 times delta r plus c sub 2 times delta s is equal to negative b sub o. Step 6. The new r and s becomes r new is equal to r old plus delta r, and s new is equal to s old plus delta s. Step 7. Repeat from step 2 until the stopping criterion were reached. Then refer to the formula. Absolute value of E sub A of R is equal to absolute value of delta R over R times 100%. And absolute value of E sub A of S is equal to absolute value of delta S over S times 100%. Step 8. Use the quadratic formula of x is equal to r plus minus square root of r squared plus 4s all over 2 to get the first two roots of f of x. Step 9. Divide f of x by the formula of x squared minus xr minus s using the latest value of r and s. Step 10. If the quotient is a third order or higher, use Bairstow's method again using the latest value of r and s to find the other roots. Then, if the quotient is quadratic, use the formula in step number 8.
Ang Bairstow's method ay isang iterative method na ginagamit para mahanap ang real at complex root ng ating function or polynomial. Dinidivide ng Bairstow's method ang polynomial sa quadratic function na x squared minus rx minus s. Let's say, meron tayong function of x. I-divide natin to sa x squared minus rx minus s. Kapag dinivide natin ito sa quadratic function na x squared minus rx, magkakaroon tayo ng quotient na polynomial na f of n minus 2 of x is equal to b sub 2 plus b sub 3 of x plus b sub 4 of x squared, and so on. At may remainder tayo na linear function, let's say rx is equal to b sub 1 of x minus r plus b sub 0. Since yung quotient natin at ang remainder ay nakukuha gamit ang standard synthetic division, the coefficient of b sub I, where I is equal to 0, can be obtained by the following recurrence relation. Ito nga yung b sub n is equal to a sub n. b sub n minus 1 is equal to a sub n minus 1 plus r b sub n. b sub I is equal to a sub I plus rb sub I plus 1 plus sb sub I plus 2, where yung I natin is equal sa n minus 2 to 0. So guys, kapag yung quadratic function ay exact factor ng f of x natin, then yung remainder natin ay 0. At yung real and complex roots natin ay quadratic function naman ng function of x natin, we can note na yung quadratic function is based on same guess natin ng R and S. Yung Bairstow's method nga ay parang ano din, parang Newton-Raphson method na dinidetermine natin yung values ng R and S natin na kung saan yung remainder natin magiging 0. Since yung b sub o natin tsaka b sub 1 natin are function of R and S, we can have the Taylor series expansion of b sub 0 and b sub 1 as b sub 1 of R plus delta R and S plus delta S is equal to b sub 1 plus partial derivative of b sub 1 over partial derivative of R times delta R plus partial derivative of b sub 1 over partial derivative of S times delta S plus 0 times delta R square and delta S square. And yung b sub 0 natin is R plus delta R and S plus delta S is equal to b sub O plus partial derivative of b sub O over partial derivative of R times delta R plus partial derivative of b sub O over partial derivative of S times delta S plus 0 times delta R square and delta S square. So guys, pag sinimplify natin tong equation na to, pwede na natin tong cancelin. Kaya ang matitira na lang sa b sub 1 natin ay partial derivative of b sub 1 over partial derivative of R times delta R plus partial derivative of b sub 1 over partial derivative of S times delta S is equal to negative b sub 1. Ngayon, para naman sa b sub o natin, pag sinimplify natin, ito yung matitira. Partial derivative of b sub o over partial derivative of R times delta R plus partial derivative of b sub o over partial derivative of S times delta S is equal to negative b sub o.
Dito sa equation na to, masosolve na natin ang delta R and delta S. In turn, magagamit natin to para mapa-improve natin ang ating R and S na initial guesses natin to R plus delta R and S plus delta S. So, ayan. Now, we can calculate the percentage of approximate errors in RS by E sub A R Now, we can calculate the percentage of approximate errors in R and S by using this E sub A R is equals to delta r all over r absolute times 100%. And para naman sa S, EAR S is equals to delta S all over S times 100. If E A R is greater than ES, or absolute value of EAS are greater than ES, where ES is the iteration stopping error, then we repeat the process with the new guesses of R plus delta R S plus delta S. Otherwise, the root of f of n x can be determined by the quadratic formula. Ang ating quadratic formula is r plus r squared plus 4s all over 2. To solve the system of equation, partial derivatives of b sub I all over partial derivatives of r delta r plus partial derivative of s delta s is equals to negative b sub 1, and then partial derivatives of b sub o all over partial derivatives of r delta r plus partial derivatives of b sub o all over partial derivatives of s delta s is equals to negative b sub o. We need the partial derivatives of b sub o and b sub 1. Bairstow has shown that these partial derivatives can be obtained by synthetic division of f of sub n minus 2 of x, which amounts to using the recurrence relation of an is equals to bn, or bn is equals to an, and b sub I is equals to ai plus rbi plus 1 plus sb sub I plus 2 for I is equals to n minus 2 to 0. Where partial derivatives of b sub 0 all over partial derivatives of r is equals to c1, and partial derivatives of b sub 0 all over b sub s is equals to partial derivatives of b sub 1 partial derivatives of r is equals to c sub 2 natin. Tapos, partial derivatives of b sub 1 all over partial derivatives c3 natin. Therefore, the system of equation ng c sub 2 delta r plus c3 delta s natin is equals to negative b sub 1 b sub 1, and yung isa naman is c1 delta r plus c2 delta s is equals to negative b sub 0. This equation can be solved for delta and used to improve the guesses of r and s natin. 2 r plus delta r s plus delta s. Now we can calculate the percentage of approximate errors in r s natin by e sub a delta r all over r times 100% and s naman is times 100.
Okay, so sa example natin, meron tayong f of x is equal to x raised to 4 minus 5x cubed plus 10x squared minus 10x plus 4. At meron tayong stopping criterion na 0.01. So, unang step natin ay mag-guess tayo ng initial values for r and s. Meron tayong 0.5 for and then s na negative 0.5. Then, sa next step natin, i-divide natin yung function na to sa equation na x squared minus r times x minus s. So, i-substitute muna natin yung values ng r and s dito sa equation na to, which is x squared minus 0.5 times x, then plus 0.5. So, sa pagdi-divide, using synthetic division, i-divide natin tong function na to dito sa equation na to. Unang step natin is i-bring down natin yung coefficients ng function na to dito. So, sa x raised to 4, meron tayong 1, negative 5, positive 10, negative 10, at positive 4. Sa pagdi-divide sa synthetic division, kunin natin yung unang value, invert natin yung sign pag dalawa gagamitin natin value ng r at ng s. So, para sa unang value, invert natin yung sign na to, magiging 0.5, at yung sa s natin, magiging negative 0.5. Okay, so unang step, piling na natin yung 1, then 1 times 0.5, dito sa part na to, dito natin simulan, 0.5, then 1 times negative 0.5, of course, negative 0.5. Then, pagtasin na natin yung values na to, you have negative 4.5. And again, times natin dito, negative 4.5 times 0.5 is negative 2.25. Of course, negative 4.5 times negative 0.5 is positive 2.25. Plusin natin yung values ito, makakuha tayo ng 7.25. And again, 7.25 times 0.5 is equals to 3.625. And times the negative number, negative 3.625. So, sum neto is negative 4.125. Then lastly, negative 4.125 times 0.5 is negative 2.0625. At ang sum neto is negative 1.6875. So, guys, ine-neglect na natin yung value ng or yung step sa mga remainders, yung rules. Then, after nun, next step is i-label natin yung mga results ng B4, B3, B2, B sub 1, and B sub 0. So, kung ilan yung exponent ng ating function, yun din yung unang sub ng ating B. Okay, next step naman, synthetic division ulit using the same values of R and S. So again, bring down 1 times 0.5, then negative 0.5. We have here negative 4 times 0.5 is negative 2, so times positive 2. Then the sum of this is 4.75. Then 4.75 times 0.5 is 2.375 times the negative value, negative then 2.375. So sum neto 0.25. 0.25 times 0.5 is 0.125. Ang sum nito ay negative 3.9375. And guys, sa second part ng ating synthetic division, kahit di na natin kunin yung last part ng synthetic division, itong part na to. Kasi, gagamitin lang natin is yung part na to, hanggang C sub 1 lang. Label natin to C sub 4, C sub 3, C sub 2, and C sub 1. So, itong C sub 0, hindi na natin gagamitin yan. Kaya sa mga next iteration natin, kahit hindi natin kuhanin yung part na to. So, ayun. Next step natin is from the equation na C sub 2 delta R plus C sub 3 delta S is equal to negative P1 at C sub 1 delta R plus C sub 2 delta S is equal to negative P0. Yan ang gagamitin natin, guys, class, para makuha natin yung delta R, delta S using matrix. So, sa pag-solve ng okay, so i-substitute muna natin yung mga values ng C at ng B. So, C sub 2, meron tayong 4.75 delta R plus C sub 3, so negative 4 delta S is equal to negative B1. So, ang B1 natin is negative 4.125, so magiging positive na yan. Magiging 4.125. Then, sa C sub 1 natin, meron tayong 0.25 delta R. Then, plus C2. C2 natin 4.75 delta S is equal to negative B sub 0. So, B sub 0 natin is negative 1.6875. So, naging positive yan. So yun guys, kunin muna natin yung determinant. So D is equal to 4.75, 0.25, negative 4, positive 4.75. So, sa pagkuha ng determinant is multiply downward diagonally. So, 4.75 square minus value ng 4.75 square minus 0.25 times negative 4. So, makukuha nating value dito sa determinants is 23.5625. So, meron na tayong value ng ating determinant. Yan. So, sa pagkuha ng ating delta R, i-substitute na natin constant. So, 4.125, 1.6875, then ito, negative 4, 4.75 over yung ating determinant na 23.5625. So, magiging sagot dito is 1.11804. So, meron na tayong value ng ating delta R. Sa pagkuha naman ng delta S, ganun din. Kuha natin 4.75, 0.25. So, dito naman sa row na to, yung ating constant na 4.125 tsaka 1.6875 over the determinant 23.5625. Makakuha tayo ng value na 0.29642. Mayroon tayong value ng ating delta S. Katapos nun, para makuha yung bagong value ng ating R and S, pagpaplasin lang natin yung dating R tsaka yung ating delta R old, which is delta R 1.11804 plus yung luma nating R, which is 0.5. And we have the value ng bagong R na 1.61804. Ganoon din para sa pagkuha ng bagong S, yung delta S plus lumang S natin, which is equal to 0.29642 plus negative 0.5, which is negative 0.20358. So, yung mga value natin dito guys is naka-fix siya sa 5 decimal values. Okay. So guys, ngayon, ipoprove natin to or ulitin natin yung mga step until hindi natin na-reach yung criteria natin na 0.01. So, para ma-prove yung criteria natin, we refer to the formula na Ito is absolute value ng ating delta R over bagong R times 100%. Para to sa R. So, yung time value na 1.11804 over 1.61804. Absolute value times 100% will be equal to 0.69098. Para naman sa S, same procedure lang. Absolute value ng ating delta S at ating bagong S, which is 0.29642 over negative 0.20358 times 100%. Meron tayong value, naging answer na 1.45604. So guys, ito nakita natin, hindi siya nag-less sa ating criterion na 0.01. So, ulitin natin yung step 2 hanggang step 6 until makuha natin to. Until ma-reach natin yung criterion na to. Guys, hindi natin na-reach yung ating criterion, which is 0.01. So, ulitin natin yung from step 2 to step 6. So, meron tayong panibagong value ng R, which is 1.61804, at panibagong value ng S, which is negative 0.20358. So, ito yung gagamitin natin at same values ng function natin, which is 1, negative 5, positive 10, negative 10, at 4. So, divide ng R at ng S. Bring down natin yung 1 at 1 times value of R, which is 1.61804. 1 times value of S is negative 0.20358. So, ang sum neto is negative 3.38196 times value ng ating R is 6.99684. Then, negative 3.38196 times value ng S is equal to 0.68850. The sum neto is 4.32427 times the value of R, which is 6.99684, times the value of S, we have negative 0.88033. Sum neto, right, negative 2.31466 times the value of R, lastly, should be negative 3.74521. Then the sum be negative 0.62554. And then again, we label this as B4, B3, B sub 2, B sub 1, and B sub 0. Step, divide by the same value of R and S, 1.61804. S is negative 0.20358. So again, bring down 1, value ng R, 1.61804, and value ng S, negative 0.20358. Yung sum nito is negative 1.7 0.6392 times the value of r, which is negative 2.8409. At sum ng values ito will be 1.26660 times the value of r, the value of s will be 0.3590, then 1.26660 times the value of r, which will be 2.04941. And sum ng values ito is 0.09385. Then again guys, stop na tayo sa C1 kasi hindi naman natin gagamitin yung C sub 0. So we label this C4, C sub 3, C sub 2, and C sub 1. Then again, sa pagkuha ng ating delta R, meron tayong formula. I-substitute na natin. Delta R minus 1.76392 dahil negative ang ating value times delta S is equal to negative B1. So, ang B1 natin is negative 2.31466. So, magiging positive. Then sa pangalawa, 0.09385 delta R plus ating C sub 2, which is 1.26660 delta S is to negative B sub 0, which is negative 10, so magiging positive 0.62554. So again, kunin natin yung determinant. So makuha natin yung determinant. And then next, kunin natin yung determinant. So sa pagkuha ng determinant, list na natin yung values 1.660, 0.09385, then negative 1.76392, 1.26660. So downward times upward. So makuha natin yung value na 1.76982. So sa pagkuha ng delta R, substitute may constant dito. So meron tayong 2.31466 at 0.62554. Then yung value ng sa delta S natin 1.76392 at 1.26660 over ating determinant na 1.76982 at magkakuha natin tayo ng value na 2.27998. At para sa delta S, ganun din. So, listaw natin yung value na 1.26660 at 0.09385. Then, yung constant, substitute natin dito, 0.31466 at 0.62554 over at the determinant 1.76982, which is equal to 0.32494. Then, next step is kukuhanin natin yung bagong value ng ating R, which is delta R plus dati nating R. 2 plus 2.718, which is equal to 3.89802. At bagong value ng ating S is delta S plus dating value ng S, which is negative 0.20358 plus 0.32494 should be equal to 0.12136. And then again, prove natin yan. Absolute value ng ating delta R, which is 2.2798 over bagong value ng R, which is 3.89802 times 100%. Mag-equal yan sa 0.58491. At same thing para sa proof na ating S. This absolute value of delta S 0.32494 over bagong value ng S 0.12136 times 100%, which equals to 2.67749. So yun guys, makikita natin hindi pa rin niya na-reach yung ating stopping criterion, which is 0.01. So isang iteration ulit. Okay class, nasa pangatlong iteration na tayo. Bagong value na naman ng R, which is 3.89802 at bagong value ng S, which is 0.12136. Of course, synthetic division ulit natin sa value na ating function, coefficients, -10 and 4. So bring down 1 times value ng R, 3.89802 at value ng S, 0.12136. Sum na itong values na to is -1.10198, and then times the value of R will be -4.29554 at times value ng S, which is -0.13374. At sum ng values ito is 5.82582 times the value of R again, which would be 22.70916. Then sum ng values ito is 12.57542. Then 5.82582 times 0.12136 is 0.70702. 12.57542 times the value of R is 49.01924. At sum nito is 53.72626. So label again these results as B4, B3, B2, B sub 1, and B sub 0. And again, synthetic division, same values ng ating R and S, 0.12136. So bring down 1 times the value of R is 3.89802, and then the value of S 0.12136. Then sum ng values ito is 2.79604 times the value of R is 10.89902 times the value of S is 0.33933, and the values of the sum of this is 16.84620. Then lastly, times the value of R is 65.8 66682, which is our C1 58157. Label this as C4, C sub 4, C sub 3, C sub 2, and C sub 1. Then next step again, para sa pagkuha ng ating delta R and then delta S, substitute natin sa formula na delta R plus C3 is 2.7904, delta S is equal to negative P1, which is negative 12.57542, and then C2 delta R, which is C1 delta R, which is 78.58157 delta R, plus C sub 2 16.84620 delta S is equal to negative B sub 0, which is negative 53.72626. Then next, kunin ulit natin yung determinant gamit ang matrices. So, ito. Gusto natin yung values. 620, 78.58157, then positive 2.7904, 16.84620. So, pag times lang natin yung values downward minus upward. So, makakuha tayo ng value na ating determinant na 64.07724. So, pagkuha ng ating delta R, of course, substitute na natin constant dito, which is negative 12.57542 at negative 53.72626. Then, ating delta S 604, and then 16.84620 over the determinant 64.07724. Makakuha tayo na value na ating delta R na negative 0.96177. Sa pagkuha ng delta S, substitute ulit natin yung constant, which is dito sa delta S, then delta R muna is 16.84620, 78.58157. Then yung constant natin dito is negative 12.57542 and negative 53.72626 over the determinant 64.07724, at makakuha tayo ng value ng ating delta S, which is 1.29707. Then, sa pagkuha nating panibagong R, is pagtasin lang natin yung dating R natin at yung delta R, which is equal to 2.93625. Ating bagong S, dating S plus delta S should be equal to 1.41843. So, ito ang panibagong value natin ng R, which is 2.93625, at panibagong value ng S, which is 1.41843. So, prove na naman natin yung stopping criterion. So, para sa R, absolute value ng delta R, which is negative 0.96177 over new value ng R, which is 2.93625 times 2%. Will be equal to 0.32755. And para sa ating S, absolute value ng ating delta S, which is 1.29707 over panibagong value na S, which is 1.41843 times 100%, which equals to 0.91444. So, ayun guys, di pa rin natin na-reach yung stopping criteria natin. So, we will proceed sa step 2 to step 6. Ulit-ulitin natin hanggang sa marating natin yung ating stopping criterion. So, yung huling value ng R natin, we have 2.98394. At para sa ating S, we have the value negative 1.96464. So, continuing iteration, we divide this again by synthetic division. 1, negative 5, 10, negative 10, and 4. We divide this by the value of R and S. 1.96464. At para sa value na S, we have negative 1.96464. So, let's bring down 1. 1 times the value of R is 2.98394. And times the value of S, we have negative 1.96464. So, the sum this value is negative 2.01606 times the value of R, we have negative 6.01580 times the value of S, we have 3.96083. So the sum of these values is 2.01956 times the value of R, we have 6.02625 times the value of S, we have negative 3.96771, and the sum of this is negative 0.01292. Lastly, times the value of R, we have negative 0.03855, and the sum of this is negative 0.00626, and again we label this as B sub 4, B sub 3, B sub 2, B sub 1, and B sub 0. Then again, we divide it by synthetic division by the same values of R and S. So bring down 1 times the value of R, 2.98394, and the value of S, negative 1.96464. So the sum of this is 0.96788 times the value of R, we have 2.88810 times the value of S, we have negative 1.90154. So the sum of these values is 2.94302. Lastly, 2.94302 times the value of r, we have 8.78180. The sum of this is 6.86734. We label this as C4, C sub 3, C sub 2, and C sub 1. So, then again, substituting this to this formula, C sub 2, 94302 delta R plus C3, C3.96788 delta S is equal to negative B1, which is negative, so we have a positive 0.01292, and then C1, 6.86734 delta R plus C2, 94302 delta S equal negative B sub 0. We have a negative, so we have 0.00626. So getting the determinant, again, use matrix 2.94302, 6.86734 at itong 0.96788 para sa ating delta S, 2.94302. So again, multiply downward minus multiply the upward values. So we have the determinant 2.01461. So solving for delta R, substitute the constant here. So 0.01292 and 0.00626, then 0.96788 and 2.94302 over the determinant 2.01461, which will result to delta R 0.01587. At pagtapos, para sa ating delta S, ganun din, we have value of 2.94302 at 6.86734. Tapos yung constant natin, 0.01292 at yung 0.00626 over the determinant 2.01461, which will result to the value of our delta S, which is negative 0.03490. So kunin ulit natin yung ating bagong R, which is delta R plus ating lumang R, which is equal to 2.9981. At ating bagong S, which equals to delta S plus dating S, which is equal to negative 1.99954. So again, prove natin siya. Yung ating delta R, para sa ating R, delta R 0.01587 over bago nating R, which is 2.9981 times 100%, which we have 0.00529. Then para sa ating S, we have delta S 0.03490 over ating bagong S, which is negative 1.9954. Absolute value times 100%, which will result to 0.01745. So guys, nakita natin dito Yung stopping criteria natin, nakuha natin sa R, pero sa ating S ay hindi pa rin dahil masigit pa rin siya sa 0.01 kasi mas malaki pa rin siya. So, isa pa tayong iteration. Let's see kung makukuha na natin siya this time. So, bagong value ng ating R is 2.9981 and then para sa S, negative 1.9954. So then again, synthetic division, value na 1, negative 5, 10, negative 10, and 4. So again, bring down 1. We have the value of R, 2.9981, value of S, negative 1.9954. So the sum of this is negative 2.00019 times the value of R, we have negative 6.00019 times the value of S, we have 3.9946. So the sum of these values are 2.00027 times R again, we have 6.00043 times the value of S, we have negative 3.99962. Then the sum of these values are negative 0.00011. Lastly, times the value of R, we have negative 0.00023. Then the value of this sum is 0.00005. So again, we label this by B4, B sub 3, B sub 2, B sub 1, and B sub 0. So yun guys. Synthetic division ulit by the same values of R, which is 2.9981 at yung value ng S, which is negative 1.9954. Bring down 1, the value of R, 2.99981. Then the value of S, negative 1, sorry, is positive, negative 1.9954. So the sum of this is 0.99962 times the value of R, we have 2.99867 times the value of S, we have negative 1.99878. The sum of these values is 2.9940. Lastly, times the value of R, we have here 8.99763. Lastly, the value of this sum is 6.99874. So we label this again as C4, C sub 3, C sub 2, and C sub 1. So again, from the formula, C sub 2, delta R, we have 2.9940 delta R plus del C3, which is 0.9962 delta S, equal to negative B sub 1, which is negative 0.00011. So it will become positive. Then C sub 1 delta R, which is 6.99874 delta R plus C sub 2, which is 2.99940 delta S, is equal to negative B sub 0, which is 0.005, so it will be negative 0.005. So by getting the values of A sub delta R, we get the determinant. Again, you have 2.99940, 6.99874, 0.99962, and 2.99940. So again, downward minus upward, which is equal to determinant 2.00032. So again, to get the value of delta R, we substitute the constant here. 0.0011 and negative 0.0005. Then the value of 3962 and 2.99940 over the determinant 2.00032, which will be equal to delta R 0.00019. And for delta S, we have 2.9940, 6.99874, and the constant 0.0011 and negative 0.00005 over the determinant 2.0032, which will be equal to our delta S negative 0.00046. So getting the new R and the new S, we have to get the sum of the R old and the delta R for the new R. So we have now the value of 3, and for S, we have the value of negative 2. So okay, now we prove this. By this formula, delta R over the new value of R, which is 3 times 100%, which is equal to 0.00006. And for S, we have delta S, which is negative 0.00046 over negative 2 times that value times %, which is equal to 0.0023. So yun guys, nakita nga natin. So na-reach na niya yung stopping criterion. Less than 0.001 na siya. Parehas ng value. Yan guys, after 9 iterations, nakuha na natin yung ating stopping criterion, which is should be less than 0.01. So ang next step natin is gamitin na yung formula na ating quadratic formula, which is x is equal to r plus minus square root of r squared plus 4s over 2. Gagamitan natin itong formula na to para makuha natin yung unang roots. So, isubstitute lang natin yung value ng r tsaka ng s sa loob dito. So, we have r 3 is minus square root of r squared, which is 3 squared plus 4s, 4 times negative 2 over 2. So there we have x will be equal to 3 plus or minus square root of 9 minus 8 over 2 is equal to 3 plus or minus square root of 1, which is 1 over 2. So yun guys, makuha natin dito yung dalawang value ng roots natin, which is 3 plus 1 plus 4 over 2, which meron tayong 2 at meron tayong 1. So plus, nakakuha na tayo ng dalawang roots. So yung given natin is, yung pinakamataas na exponent niya is 4. So ibig sabihin, meron tayong 4 na roots. So yung dalawa pa, hanapin natin. So moving on to step 9, i-divide natin yung function natin by the equation x squared minus r times x minus s using yung latest value natin ng r tsaka s, which is equals to 3, at yung s natin is equal to negative 2. So substitute muna natin dito, x squared minus r, which is 3, times x minus s minus negative 2 equals to plus 2, at i-divide natin siya sa ating function, which is x raised to 4 minus 5x cubed plus 10x squared minus 10x plus 4. So yung gagawin natin dito guys, hindi na synthetic division, pero normal na division na lang. So ayun, so pag-divide, kunin muna natin yung sa unang function para makancel tong term na to. So ano yung pwedeng i-times dito para makakuha ng x sub 4, ay x raised to 4. So pwede dyan is x raised to 2. So x raised to 2 times x raised to 2 is x raised to 4, and x raised to 2 times 3x is negative 3x cubed. X squared plus 2 is 2 kasi 2x squared. So i-minus natin, maka tayo na sagot. Makakancel na to, then negative 2x cubed, then 10x raised to 2 minus 2x raised to 2 is positive 8x raised to 2. So bring down natin tong 10x. So again, ano yung pwede mong i-times dito para makancel yung negative 2x cubed. So pwede dito is negative 2x. So natin negative 2x. Negative 2x times x squared is negative 2x cubed. Then 2x, negative 2x times negative 3x is positive 6x squared. And then negative 2x times 2 is negative 4x. And again, minus natin. So makakancel to. Then we have 2x squared minus 6x. And again, last term, bring down natin, plus 4. So ano again yung pwedeng term para makancel tong 2x squared. So pwede dyan is 2, positive 2. So we have 2 times x squared is 2x squared. Then 2 times negative 3x is negative 6x. And 2 times 2 is positive 4. So yun guys, na-cancel na lahat. Nag-0 na siya. Cancel. So, there. So ngayon guys, if yung quotient na lumabas dito is in third order or higher, sabihin if x cube siya or higher, ang gagawin natin is ulitin natin yung Bairstow's method. So ngayon synthetic division tayo katulad sa una. Pero sa case na to, pwede na natin makuha yung dalawa pang natitirang roots natin. So equate lang natin yung quotient to 0, x squared minus 2x plus 2 is equal to 0. Then lipat natin yung 2. So negative 2. So ayan. Paano natin masisimplify itong equation na to? So pwede natin gawin, magdagdag tayo ng 1 sa parehas sa side. So x squared minus 2x plus 1 is is equal to negative 2 plus 1. So, mas-simplify ito sa x squared minus 2x plus 1 is equal to negative 1. So, i-simplify pa natin. Ano pwedeng gawin? So, simplify natin itong term na to. Itong term to is also equal to x minus 1 squared. Yan. So, para makancel yung square root natin siya. Itong kabilang side. So, cancel. So, we have x minus 1 is equal to square root of negative 1. So, continuing. X minus 1 is equal to imaginary number and then x minus 1, so transpose na natin yung negative 1. So we have x is equal to 1 plus or minus imaginary number. So and guys, meron tayong dalawa pang roots, which is 1 plus I at 1 minus I. So ayun, therefore, ang roots ng ating function na x raised to 4 minus 5x cubed plus 10 x squared minus 10x plus 4 ay 2, 1, 1 plus I at 1 minus I. Ito na ang ating final answers.